Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video. And today's video is about another interesting concept in the subject electrical and electronics engineering. We're going to see problems on Thevenin's theorem. In previous video, I have explained what is Thevenin's theorem, what are the rules and regulations to solve Thevenin theorem circuits, right? And we have seen problems also. I would recommend you people to go through that video first so that you can understand the basics about Thevenin's theorem so that you can easily understand these problems, right? So with this, we will start this particular video, right? I'll just refresh the procedures which I explained in previous video. The very first step you got to do is you got to draw the Thevenin equivalent circuit, and then you need to find out VTH. How will you find out VTH? You'll have to remove the load resistance, and then we got to find out VTH, and then we need to find out RTH. For finding out RTH, you got to remove load resistance and also the source. For killing the source, if it is voltage source, you got to short circuit, and if it is current source, you have to open circuit, right? And then at last we need to substitute the values of VTH and RTH in equivalent circuit, and you need to find out the values of RL, right? This is what I explained in previous video also. So now we'll see another problem here. Find the current through the load resistor 5 kilo ohm using Thevenin's theorem, right? The very first thing is they are already given here load resistor as 5 kilo ohm. So this is the load resistor. Even if they are not mentioned as load resistor, if any resistor value is mentioned, that will be considered as load resistance, right? I've already said in Thevenin's theorem, what is the very first step we have to do? We have to draw Thevenin equivalent circuit, right? So what is Thevenin equivalent circuit? This is the very first step we have to do. We're going to draw a voltage source which is VTH, and then a resistance, right? This is RTH, this is VTH, and this is RL. This is another resistor which is RL, right? RL alone we know that it is 5 kilo ohm. Everything is given as kilo ohm here. So now what we have to find out? We have to find out VTH and then RTH, and then we have to substitute those values here, and then we need to find out the load current, right? So now what I'm going to do, I'm going to find out VTH. How will I find out VTH? I have to remove this load resistance from the circuit, right? So if you remove the load circuit, what we got to do? We have to use the same circuit but without load resistance, right? So the same circuit, right? But without load resistance, which means this will be A and B. And this voltage across this A and B is VTH. Correct? This is VTH, right? Which means the voltage across this resistor, that is VTH. So here it is 4 kilo ohm, and this is 12 kilo ohm, and this is 8 kilo ohm, right? Now, how will you find out this is 48? So we need to find out VTH. For that, first I need to find out the current I, right? So how will you find out I is equal to V by R, V by R. And before that, you understand here, we have a voltage source here, so the current will flow in this direction, right? We have removed the load circuit, right? So this 8 kilo ohm becomes inactive, right? Because this is a closed path, this is the open path, right? And we don't have any sources here, and this 8 kilo ohm is neglected here. So now what does it mean? So VTH is 48 ohm, and resistance value 12 plus 4, 16, right? So both are kilo ohms. So you have 16 kilo ohm, 16 kilo ohm. So which means current will be 3, right? 3, and it is kilo ohm here, so it will be 10 to the power of 3 here, and if it goes up, it will be milliamp, right? So it will be 3 milliamp, 3 milliamp, correct? It will be 3 milliamp. Now we need to find out VTH. We need to find out VTH. How will I find out VTH? VTH is equal to the current across this particular resistor, right? So the value is here, it is given as 4 kilo ohm, which means 4 into 10 to the power of 3, right, into the current value 3 into 10 to the power of minus 3, right? It is 3 milliamp. So this will get cancelled. So it will be 12 volt. It will be 12 volt. So what is VTH? VTH is 12 volt, right? And what is the next step we need to find out? We need to find out RTH. We need to find out RTH. How will I find out RTH? For finding out RTH, first step you have to do is you have to remove the RL and also you have to remove the source. Removing the source in the sense, if it is voltage source, we will short circuit it, right? And so the circuit will become like this, right? The circuit will become like this. We have to remove the load resistance as well, right? Now this is 12 kilo ohm and this is 4 kilo ohm and this is 8 kilo ohm, right? Now what we have done is we have removed this particular RL. Now understand very carefully here. In VTH we had the voltage source, so we have neglected this particular resistor because it is open. But here to finding out RTH, we are approaching the circuit from this direction, which means the current gets split here. So here 12 and 4 becomes parallel, right? Whereas this becomes series, right? So finding out RTH, first you need to simplify this circuit, correct? So how will I simplify? I consider this as parallel connection. So it will be 12 into 4, that is R1 into R2 divided by R1 plus R2. So it will be 12 into 4 divided by 12 plus 4, right? Everything is in kilo ohm, right? So here it becomes 48 divided by 16. So it will be 3 kilo ohm, right? So this 3 kilo ohm, now the circuit will become like this, right? This circuit will become like this, right? So it will be 3 kilo ohm, right? And this will be 8 kilo ohm. Or you can also draw series like here, right? So now this is series. So it will be RTH, it will be 8 plus 3, 11 kilo ohm. 11 kilo ohm. Understand how we got RTH? We have simplified this parallel connection and then we have added this resistor. So now we have found out what is VTH and what is RTH value, right? And now we have to substitute that value here in this particular circuit, correct? How will I do that? Now I'll redraw this. First we will write these values. VTH is equal to 12 volt and RTH is 11 kilovolt, right? So now we will find out RL, right? How will I find out RL? I'll redraw the sequence circuit again. You know that VTH is 12 volt. So VTH is 12 volt. Now you substitute this here, right? This equivalent circuit, right? This will become 12 volt, right? That is VTH and RTH you substitute 11 kilo ohm and then RL is 5 kilo ohm. We need to find out IL for this particular circuit, correct? So IL is equal to V by R. So it is 12 volt divided by 11 plus 5 kilo ohm, that is into 10 to the power of 3, right? So it will be 12 divided by 16. 12 divided by 12 divided by 16 into 10 to the power of 3, right? So what is the answer you will get? We'll just check it out. It will be 12 divided by 16. So it will be 0.75. So which means 0.75 milliamp. Milliamp. That is the correct. That is the correct. Right? So you understand how we have solved this problem. It is the same steps, right? I'll show how we have solved it, right? So you can see this particular circuit, right? First thing is we have drawn the equivalent circuit with 5 kilo ohm as load resistor, and then we have find out VTH, whereas VTH we have find it out, we have removed the load resistor, right, and then we have eliminated this particular resistor, and then we have obtained as 3 milliamp, right. We have to find out the voltage across this particular resistor, so it will be 12 volt, and then we have to find out RTH. For RTH, what we have done is we have taken this to as parallel connection, right? So we obtained 3 kilo ohm. So RTH become 11 kilo ohm, right? And then we found out the final value of IL current, which is 0.75 milliamp, right? The same steps. You have to follow the steps very clearly so that you can not have any problem while solving it, right? So now we'll see another problem here. So if you say another problem, so in this problem, you see here, find out the current flowing through 50 ohm resistor, right? So it is again 50 ohm resistor, but this is a different problem where you can see three meshes here. So how will I solve that? Same steps. First step, what you got to do? Draw the Thevenin equivalent circuit, VTH, RTH, and the load resistance is 50 kilo ohm, right? And what is the second step? We need to find out. We need to find out VTH. For that, what we got to do? We have to remove this load resistor, correct? So what I am doing is I am removing the load resistor. So if I remove the load resistor, now what will happen? The circuit will become like this. So you'll have I1, I2, right? And you can eliminate this 15 ohm, right? And now this becomes mesh. You can use mesh analysis. You can use equation method or matrix method. Here they have used matrix method. You know how to solve the matrix method, right? So here it is two meshes. So for resistor alone, you have R 11, R12, R21, and R22. You know this, right? The same thing you have done. You can see here R11, this is total resistor, which is 30, right? And then R12 is nothing but the common resistor, which we have to do its minus because diagonal element, minus 20, right? And similarly, again, it's R21 minus 20. And then you have R22. R22 is nothing but this particular complete resistance, 20 plus 20 plus 30, which is 70, right? And then you can solve the equations using calculator, right? Now we need to find out the voltage across this particular resistor, right? So we need only I2 because this is the current which is flowing this particular resistor. So I2 value is 1.17, which is obtained through solving this particular expression, right? So and then we have multiplied that current with the this particular resistor, so we have obtained the voltage as 35.328. And now we need to find out RTH. For RTH, what you will do, you have to short circuit this particular voltage source as well, and then remove the load resistor as well. So the same circuit will become like this, right? And now what happens? Now what we have to do, we have to find out the resistor. You can see here we are approaching the circuit from this end. From this end, if you are approaching from this end, now what happens here? You can see everything becomes parallel, right? Only these two will be series, all this will become parallel, right? So in that case, first thing we have to complete this parallel connection 10 and 20, where that is simplified as 6.67, right? And now what happens here? this becomes this becomes series, right? This becomes series, right? Whereas we can write it as 26.67, right? And now these two becomes parallel, and if you solve R1 and R2, R1 plus R2, you obtain this particular expression. And then finally we add this with this particular resistor to find out RTH, which is 29.1, right? Same steps which we did in previous problem. Now we will find out what is RTH and what is VTH. So substitute RTH, VTH, and find out the IL value, which is V by R, right? So R here is series resistance, so we'll obtain 0.44 ampere, right? So it is the same steps irrespective of how complex the circuit is. You follow the same steps so that you can able to obtain the answer, right? So today what we have seen is we have seen two important problems in Thevenin. I believe this video will be useful for you. Thank you, my dear students.